Hello and welcome. Today we are making benzoquinone. Benzoquinone, also called 1,4-benzoquinone or paraquinone, is a planar six-membered ring compound with the formula C6H4O2. Quinones are fully conjugated cyclic diones. They are derived from aromatic compounds such as benzene or naphthalene by converting an even number of vinylic groups into carbonyl groups. The two carbonyl groups are what make benzoquinone a dione, and its closed ring structure makes it cyclic. It has an acrid odor somewhat like chlorine, but not identical. Care should be taken when handling it because it irritates the skin, the lungs and mucous membranes. Benzoquinone is an oxidizing, electrophilic compound. Although it can cause systemic toxicity through redox cycling, and it may be carcinogenic via benzene metabolism, these effects are fairly negligible. Its main hazard is oxidative tissue injury. Here we have made a dilute sulfuric acid by adding 9 ml of concentrated sulfuric acid to 130 ml of distilled water. For the acidic environment needed to oxidize 11.25 grams of hydroquinone using 17.25 grams of potassium dichromate. Be aware of its toxicity and how to manage the waste afterwards. Hydroquinone comes as these needle-like crystals. It is used as a developer in film photography. It forms an image out of silver by reducing silver halides to metallic silver. It's a mild, slow-working reducing agent, often paired with faster reducing agents to produce high-contrast images. We first dissolve this in our mildly acidic solution, then reprecipitate it using an ice bath. This removes soluble impurities, giving us a purer product to start with. Now we can start introducing our oxidizer to it dropwise, whilst monitoring the temperature. What happens is the two hydrogens on our hydroquinone are removed one by one, forming benzoquinone. At first, the benzoquinone will link with the hydroquinone to form quinhydrone. But on further addition and constant stirring, we end up with just our benzoquinone. A related compound is coenzyme Q10, which also contains a quinone structure and plays an essential role in cellular respiration and electron transport within mitochondria. We can fully crystallize this out by putting it in the fridge. Then we can filter and wash our product. To obtain pure benzoquinone, we perform a sublimation. By heating our crude product, the benzoquinone sublimates and we can collect a crop of crystals on a cold surface. This wasn't done perfectly, so there was some product loss. Now that we have benzoquinone, the fully oxidized form of hydroquinone, we can now make, through nucleophilic addition and a bit of proton transfer rearranging, a fun UV fluorescent compound called cyanophenol. This has three possible isomers depending on the position where the groups are on the ring. Dissolving this in DMSO and adding some sodium cyanide, we essentially add a cyano group to the quinone. and after some rearranging it becomes aromatic again.